Hello students, now in today's video we will start the 6th lesson from Geometry Standard 10th. Okay, so first we revise the part which we studied in 9th standard. This is the second part of this trigonometry. The first part we finished in 9th standard. So let us revise what we studied in 9th standard. So in 9th standard we have studied the three trigonometric ratios, that is sine ratio, cosine ratio and tan ratio, that is sine, cos and tan. Okay, these ratios we have studied. Let us revise those ratios. For that we need one right angle triangle. Okay, so this is the right angle triangle. Suppose triangle ABC. This is right angle triangle ABC. Okay, ABC. Now definition of right angle triangle we know very well. A triangle in which one angle is right angle, that triangle is called right angle triangle, and the remaining two angles are acute angles. Out of those two angles we consider theta as an angle A. Measure of angle A is equal to theta. Then for this angle theta, this side BC is called opposite side. This is called opposite side, while this side AC is called adjacent side. Adjacent side. Okay, and the side opposite to this right angle is called the hypotenuse. It is called the hypotenuse. Okay, so remember both sides. For this angle theta, if we consider angle A as measure theta, then for this angle theta, side BC is the opposite side, side AB is called the adjacent side, and AC is always hypotenuse. If we consider angle C as an acute angle, then for angle C, for angle C, this side AB is called the opposite side. Opposite बोले तो सामने की side, right? And this side BC is called the adjacent side, and this will be the hypotenuse as it is. So by using these three sides, we define three ratios, trigonometric ratios. The first ratio is called sine ratio. Okay. Second one is cosine ratio, and third is tangent ratio. Okay. But in short, we write this sine ratio as SIN, sine of theta, and we define those ratios on acute angle in right angle triangle. Okay, so sine theta is equal to opposite side of theta, opposite side upon hypotenuse. Opposite side upon hypotenuse, that is equal to opposite side is here BC upon hypotenuse is AC. So this is the definition of sine theta. This we have studied in 9th standard. Then second ratio, that is cosine ratio. In short, we write it as cos. Cos theta is equal to it is adjacent side upon hypotenuse. Now the adjacent side is AB upon hypotenuse is AC. AB upon AC. This is the second ratio. Okay, and the third ratio we have studied as tangent ratio. In short, we write it as tan theta is equal to opposite side upon adjacent side. Okay, so opposite side is BC upon adjacent side is AB. So these three ratios, sine, cos and tan, these three ratios we have defined in 9th standard. Now in 10th standard we have to define further three ratios, and those three ratios are, first one is secant, then cosecant and cotangent. These are the three ratios we have to define in 10th standard. Okay, so in short, we write secant as sec, cosecant as cosec, and cotangent as cot. Okay, so first we define sec ratio as sec theta is equal to sec theta is equal to hypotenuse upon adjacent side. Hypotenuse upon adjacent side. That is equal to, here hypotenuse is AC upon adjacent side is AB. Okay. Then cosec theta is equal to, it is hypotenuse upon opposite side. Hypotenuse upon opposite side. That is equal to, hypotenuse is AC upon opposite side, which is BC. Opposite side is BC, and the last ratio is nothing but cot ratio, as cot theta is equal to, it is adjacent side upon opposite side. That is equal to, adjacent side is AB upon opposite side is BC. Okay, so these are the 6 ratios we have to study in this lesson, trigonometry. Okay, so remember these definitions of sine, cos, tan, sec, cosec, cot. Okay, similarly, this we have written these ratios on this angle A or angle theta. You can write those ratios for angle C also. For angle C also you can write. Okay, now if you observe these 6 ratios, then the definition of sine theta is BC upon AC, and if you observe the definition of cosec theta, which is AC upon BC, that is exactly opposite or inverse. BC upon AC is there, and there is AC upon BC is there, so they are inverse of each other. Okay, similarly for cos theta, or we can write the relation as sine theta is equal to, we can write it as 1 upon cosec theta. This is the relation between sine and cosec, or cosec theta is equal to 1 upon sine theta. Remember this relation. Okay, we can write sine theta as 1 upon cosec theta, or we can write cosec theta as 1 upon sine theta. Similarly, cos and sec, they are inverse of each other. Here AB upon AC is there, and here AC upon AB is there. Exactly inverse of this. So we can write those as cos theta is equal to 1 upon sec theta, and here sec theta is equal to 1 upon cos theta. Okay, so this is the relation between cos and sec. Cos theta is equal to 1 upon sec theta, or sec theta is equal to 1 upon cos theta. Similarly, tan theta is equal to 1 upon cot theta, or cot theta is equal to 1 upon tan theta. Okay, similarly we can write tan theta as, tan theta is equal to, it is sine theta upon cos theta. Remember this value, tan theta is equal to sine theta upon cos theta, and here it is cot theta is equal to cos theta upon sine theta. This you can very easily verify. Definition of sine theta is opposite side upon hypotenuse, and cos theta is adjacent side upon hypotenuse, and you have to take ratio of this. So this hypotenuse and this hypotenuse get cancelled, and you will get opposite side upon adjacent side. Okay, and opposite upon adjacent is nothing but tan theta, and therefore tan theta is equal to sine theta upon cos theta. This is the value of tan theta in terms of sine and cos. Similarly, cot theta is equal to cos theta upon sine theta. So remember these formulas. These formulas are very important from here. These formulas are very important to solve exercise practice set 6.1. Okay, so remember these. Trigonometric identities. Okay, there are 3 identities. First identity is sine square theta plus cos square theta is equal to 1. This is the first identity, trigonometric identity. Second, 1 plus tan square theta is equal to, it is sec square theta. And third identity, it is 1 plus cot square theta is equal to cosec square theta. So these are the 3 trigonometric identities Very important identities, very important formula is this, because by using these formulas we have to solve. Practice set 6.1, very important. Okay, so remember these formulas today now. Sin square theta, learn this. Sin square theta plus cos square theta is equal to 1. 1 plus sin square theta is equal to sec square theta, and 1 plus cot square theta is equal to cosec square theta. Now we will see proof for each identity. So proof for first, we consider one right angle triangle here. Proof in triangle ABC, angle B is equal to 90 degree, angle A is equal to theta, angle A is equal to theta we consider, okay, and therefore by Pythagoras theorem, we have AC square is equal to BC square plus AB square. This is equation number 1. Okay, this is the starting part for proof of each identity. Okay, this is common part. Okay, now proof for first. Now sin theta and cos theta, sin square theta plus cos square theta is equal to 1. This we have to prove. So first we define sine ratio and cos ratio for this triangle ABC. Okay, so sine theta is equal to definition of sine theta we have studied. Sine theta is nothing but opposite side upon hypotenuse, which is BC upon AC. Then cos theta, definition of cos theta. Cos theta is equal to it is adjacent side, which is AB upon hypotenuse is AC. Okay. Now if we observe the denominator of sin theta and cos theta, then that denominator is common and that denominator is equal to AC. Okay. So we divide equation 1 by AC square. Divide equation 1 by AC square. So you will get AC square upon AC square is equal to BC square upon AC square plus AB square upon AC square. Divide equation 1 by AC square. So this AC square get cancelled. Only 1 is left, is equal to this BC square upon AC square we can write as BC upon AC bracket square plus AB upon AC, AB square upon AC square we can write as AB upon AC bracket square, and therefore 1 is equal to, now BC upon AC, if you observe BC upon AC is nothing but sin theta, so we can write it as sin theta bracket square plus AB upon AC, but AB upon AC is nothing but cos theta, so we can write it as cos theta bracket square. Okay, here just remember one thing, here in this case remember one thing, that sin theta bracket square is not equal to sin theta square. Okay, where sin theta bracket square is not equal to sin theta square. If you write like this sin theta square, then it means theta square only, but we have to take square of that ratio. So we write sin theta bracket square, or you can write it as 1 is equal to sin theta bracket square, you can write as sin square theta ratio square, okay, plus cos square theta, and therefore sin square theta plus cos square theta is equal to 1. This is the proof for first identity, sin square theta plus cos square theta is equal to 1. Yes, any doubt in this? No? Okay. Now come to the proof for second identity. Here second identity is 1 plus tan square theta is equal to sec square theta. Okay. Starting part is same, common in triangle ABC, angle B is equal to 90, angle A is equal to theta. Then by Pythagoras theorem we got this equation, AC square is equal to BC square plus AB square. Now we define ratio tan theta and sec theta. So here tan theta is equal to, now definition of tan theta is opposite side upon adjacent side, which is BC upon adjacent side is AB. And definition for sec theta. Sec theta is hypotenuse, that is AC upon AB. AC upon adjacent side. Sec theta is equal to hypotenuse upon adjacent side. Okay, so these are the definition. So tan theta and sec theta. Now if you observe the denominator for tan theta and sec theta, the denominator is common, which is AB. So just divide equation 1 by AB square. So we divide here. Divide equation 1 by AB square. So you get AC square upon AB square is equal to BC square upon AB square plus AB square upon AB square. So here this AB square get cancelled. AC square upon AB square we can write as AC upon AB bracket square is equal to this we can write as BC upon AB bracket square plus 1. Okay, now AC upon AB, but AC upon AB is nothing but sec theta. So we can write it as sec theta bracket square is equal to BC upon AB, but BC upon AB is nothing but tan theta. So we can write it as tan theta bracket square plus 1, and we can rewrite as sec square theta is equal to tan square theta plus 1. Again we can rewrite it as 1 plus tan square theta is equal to sec square theta. This is the proof for second identity. 1 plus tan square theta is equal to sec square theta. Yes, any doubt in this? No? Okay. Now come to the proof for third identity. We have to prove is 1 plus cot square theta is equal to cosec square theta. 1 plus cot square theta is equal to cosec square theta. So we define cot theta ratio as cot theta is equal to, definition of cot theta is adjacent side which is AB upon opposite side which is BC, and here cosec theta. So cosec theta is equal to hypotenuse which is AC upon opposite side which is BC. This is the definition. Okay. So by that definition, if you observe the denominator for both cot theta and cosec theta, it is BC. It is BC. So we divide equation 1 by BC square. So divide equation 1. Divide equation 1 by BC square. So you will get AC square upon BC square is equal to BC square upon BC square plus AB square upon BC square. Okay. So this AC square upon BC square we can write as AC upon BC bracket square is equal to this BC get cancelled. You will get 1 only plus AB upon BC bracket square. Now AC upon BC, but AC upon BC is nothing but cosec theta. So we write it as cosec theta bracket square is equal to 1 plus AB upon BC. So AB upon BC is nothing but cot theta. So it is cot theta bracket square, and therefore cosec square theta is equal to 1 plus cot square theta. We rewrite this formula as 1 plus cot square theta is equal to cosec square theta. So in this way we got the third trigonometric identity as 1 plus cot square theta is equal to cosec square theta. So these are the three trigonometric identities. Sin square theta plus cos square theta is equal to 1, 1 plus tan square theta is equal to sec square theta, and 1 plus cot square theta is equal to cosec square theta. ये तीनों आइडेंटिटी में से कोई भी एक आइडेंटिटी एग्जाम के अंदर ऐसा प्रूफ करने के लिए आ सकता है एग्जाम में. ओके, सो रिमेंबर दिस थ्री आइडेंटिटीज, देयर प्रूफ, and also remember these three identities because these three identities are very useful for practice set 6.1. Okay, now in next video we'll solve some examples from practice set 6.1. Thank you.